3.3 Measures of central tendency and dispersion from group data. So first we approximate the mean from a frequency distribution. And all this means is that we're finding the mean, but more so we're approximating it because it's between a certain range and you can't fully know all the data points that fall within. So we typically use the midpoint, as we'll see in a second here. But the formula for sampler population is summation notation divided by the quantitative x value discrete or midpoint frequency times total frequency. That seems really complicated, but we'll get to that in a second. Note here that we're typically dealing with continuous. So that's why we use the midpoint, but I'll explain that later. And then total frequency. So right here is where we explain it. If you're doing classes like 65 to 75, so any frequency or any data points that fall between these, you calculate the midpoint, which is going to be 70. And the midpoint formula is just 1/2 the range. So 1/2, 75. It's not the range. It would be adding them together and dividing them by 2. So it would be 75 plus 65 divided by 2. And you use that range as basically the mean values. So then you times it by the frequency of each one. And I'll explain this in Sketchpad over here. So let's do how many people at a school, how much people at a school and what age they are. So let's assume that there's a school of 20 people. And this is going to be, 20 people. This is going to be the age. So I'll just put number. And then we'll put frequency right here. Frequency is how many times it occurs. So let's assume anywhere from 0 to 10 years old. 10 to 20. 20 to 30. And lastly, 30 to 40. And we're going to assume that there's 2 children here. There's going to be 12 teenagers here, just for accuracy, and 3 20-year-olds, and 3 30 to 40-year-olds. So we can't just use any point between these. We're going to use the most accurate one, and the way we do that is the midpoint, as mentioned before. So you just take the midpoint, and the formula is just maximum plus minimum divided by 2. So this will give us 5. This will give us 20 plus 10. So we just use the upper bounds and lower bounds of the class, and class is just a certain range, and then divided that by 2 to get the mid-range, or the midpoint. So here it will be 15. And here would be 50 divided by 2, which is simply just 25. And then 70 divided by 2, which is 35. And then you just use summation notation. And summation notation looks pretty difficult, but all that means is all you're going to do here is just times this, because we're assuming that we don't know what each point actually contributes here. So we don't know how old these 2 children are right here, right? They can be 8, they can be 6. All we know is that they fall between the 0 and 10 range. So we use the middle point because we use that measure of central tendency. So then we do 5 times 2. So we're just simply going to assume that each child is 5 years old here. And we use the middle one for each one to ensure accuracy. I'm not too sure why they decided on it, but they did. 15 times 12 plus 25 times 3 plus 35 times 3. And then you divide by the total frequency, just like any other mean calculation. So it's important to note that this differs from calculating the mean regularly, because you just have to use the midpoint. That's literally the only thing, and this is how you calculate the mean with intervals or classes, as opposed to discrete values like this person is like 5 years old and we have 4. Then we can use these data points because we know how old exactly these children are. So this is an example right here. We have a score here. This is for discrete values, and everyone knows that's how you calculate the mean. So Computing the weighted means is pretty simple as well. Um, all this is calculating the mean based off the weight. So it's basically the ordinal classification, and as we know, there's four classifications in statistics. There's nominal, ordinal, um, interval, and ratio. Nominal being that you don't care about the weight or the ranking. Ordinal, you do care about the ranking. Interval and ratio are completely irrelevant here, so we're not going to focus on that. So this one seems complicated as well, but I believe I have an example right here. So let's calculate the grade point average. And we'll assume that someone has 4 A's. So let's just do grade A4. Or and let's assume she has 2 B's, and then let's assume she has 1 C. And this is the frequency, meaning how many times it occurs. So she got A's 4 times, she got B's twice, she got C's once. As we know, each A is worth 4 points in the GPA system. So we square it because it's going to be 4 times 4. And then we do, B's are worth 3, and the C's are worth 1, or 2, sorry. And then you divide by, this time you don't divide by the frequency added, you divide by the meaning added, or the impact added. So A's impact 4, B's impact 3, C's impact 2. So all we do is add them together, which is 9. And doing simple math, let me see if we could do this without a calculator. So it's going to be 24 over 9, and we can't. But I believe it's simply going to be, hold on, let me try to, it's going to be 8 over 3, so 2.6667. So you could do it without a calculator. So that's how you calculate computing things with weights, pretty much. Computing things that have impact. Now this one is a little bit more difficult, simply because it looks more difficult. It's really easy. And the only difference here is that you calculate the mean using the midpoints rather than you calculate the means using the midpoints here. So first you compute the midpoints of each class, and then compute the mean by adding the midpoints together and dividing by the frequency here. Find deviations by doing each point minus the mean. So what you're going to do is, well, it's just going to be like the regular standard deviation. You divide each data set by the mean. You square it, but this time you times the frequency that it occurs. And then use summation notation, and you do that for every data set. And then you divide it by the frequency of each data set minus 1 plus each data set, or each frequency minus 1. So summation notation just means do it for every data point. That's what you're going to think it is. I believe there's a simple explanation here. So first you find the mean by multiplying the frequency and the midpoints of each data set. So as we mentioned before, you find the midpoints of each class. You times it by how many times or how many things appear in that class. You add them together, then you divide by the total frequency, which gives you the mean. Then compute the deviations like normal, which is just subtracting each data point by the mean, squaring it, and then timesing it by, and then multiplying it by the frequency that it occurs within each midpoint, or within each class, and then you divide by the total frequency, or frequency minus 1 if it's a subset or sample. Then square root it. And variance stays the same. You just square it after you're done. So